Well, welcome to this JMP Academic Series webinar on data summary and analysis in JMP. We're going to talk about some resources for learning JMP, some places that you can go after you've finished watching this webinar if you have further questions or you want to look into more details about certain techniques. We'll talk about summarizing and graphing data in JMP. We'll talk about some basic analyses like ANOVA and regression. We'll talk about some more advanced models using the fit model platform and the predictive modeling platform. We'll look at some multivariate methods and clustering data, and then we'll end on some text summary and analysis and what you might do with unstructured text data. Okay, let's get started with resources for learning JMP. At jmp.com/teach, this is our academic webpage, and if you scroll to the bottom, you'll see some really wonderful resources for learning and using JMP. On this left-hand panel, you'll see some video options, like our Getting Started videos, which is a great place if you've never used JMP at all before. The live academic webinars, which is what you're watching right now, and when we give these, we also record them and then post them in our academic webinar library. So if you're watching this not live, you probably accessed it from our academic webinar library. There are many other topics here, and I'll mention some of these as we talk about specific topics. If you want to learn more about the ANOVA and regression options in JMP, the Teaching ANOVA and Regression with JMP webinar is a good option. Teaching Intro Stats has a lot on introductory statistics tools and teaching tools. Visualization and Graphics has a lot more about summarizing and graphing data. Data preparation and modeling will show you more of the tools for how to create new formula columns and do more data preparation and so on. So if you want to explore more, learn more options in JMP, these are really good tools. Also from our jmp.com/teach page, in the middle column are more of the textual options. So the learning library, for example, is one-page guides on a number of topics in JMP. So if you want to learn more about multivariate methods, for example, you can click on this multivariate methods section and learn about clustering or principal components analysis, etc. And you'll notice that there's a one-page guide that's a PDF that you can read through that will walk you through an example and show you an example data set you can access in JMP. And there's also a corresponding video, usually 2 to 3 minutes long, on that same topic. So I would say the two main great resources if you're just getting started in JMP would be to look through our webinar library and through this learning library on the one-page guides. We have a lot of other really fantastic resources here on this webpage as well, like the case study library, which has real-world examples with exercises. The course material library is great if you're teaching a course with JMP and you want some resources already created for you. So if, for example, you're teaching a regression modeling and analysis course, we show you all the one-page guides we think are related to that topic. We show you the case studies we think are good case studies for that topic, and other resources that we have available as well. Another excellent resource for learning JMP, besides our jmp.com/teach, is in the help menu of JMP. So I'm clicking in this journal, this .jrn journal, where I'm keeping track of the outline for what we'll talk about today. This is a specific file type that opens in JMP. And when I click in it, I get my JMP menu bar. Because I'm using JMP on a Mac, the menu bar is along the top. If I'm using JMP on Windows, the menu bar would be fused in the window that I have open in JMP. So here in the JMP menu bar at the very end, you see the Help menu option. The Help menu option has a lot of great tools here. JMP Help is a searchable help. The Books is our documentation for JMP, where you can find more information on all these topics. The Sample Data Library is a list of alphabetical, the many sample data sets that we have available in JMP. So anybody who downloads JMP has access to all these data sets. These are great if you're trying to learn how to do something in JMP and you want to go through an example, for example, from our learning library. We link to many of these data sets. Or if you're teaching with JMP, this is a fantastic resource as well. So all the data sets that I'll use today in this webinar, you can find them here in this list. So again, to get there, you go to the JMP Help menu to Sample Data Library. And if you want to explore these data sets on your own and you want to have some sense about what you can find in each data set, the Sample Data menu at the bottom of the Help is going to give you an indexed list of some of these data sets. So the full list is in the sample data directory, and the sample data gives this indexed list where you can look for data sets that would talk about a certain feature or a certain type of statistical test. The teaching resources are also available here in the help menu under sample data. And there are a lot of resources here. If you watch our teaching introductory statistics or teaching ANOVA and regression webinar videos, you'll see a lot more information about those teaching resources. The JMP user community is also very helpful. There's actually a link to get there directly from the help menu here at the JMP user community, which takes you directly to community.jmp.com. And this is where JMP users post questions or things that they've created or ideas, and you can post your own questions here, read other people's discussions, and so on. Okay, so let's talk about summarizing and graphing data in JMP. I'm going to open this big class families data set, so if you wanted to follow along, you go to the JMP help menu to sample data library and look for big class families. In this data set, you can see JMP actually allows you to have pictures as a data type. So this first column, it has the little cartoon image of these students, and then we have their name, their age, their sex, their height, their weight, and some other variables. You're going to see here along the left panel where it says columns, I have some extra icons that tell me more information about these. If you have used JMP before or watched any of our other videos, you'll already know that these little icons on the left tell you the data type. So this is nominal, name is nominal. Age, this green bars, is ordinal. Height and weight are continuous. And if you want to change that, you can just click right on them and make the change here. There are this asterisk and this plus sign, other features on the other side that are specifying extra characteristics that have been applied to these columns. Right now I want to draw your attention to the label, this little yellow tag on the picture and the name. If I right click on either of these columns and click label, unlabel, I can take away that yellow tag or I can add that yellow tag back. That's going to indicate that if I hover over a point, if I hover my mouse on a point in anything I create in JMP, those will be labels that pop up. So if I want the picture to show up whenever I look at a certain person in a plot, then I can apply this little yellow label tag. So again, I just right click and ask to add this as a label feature. So I'm going to spend a lot of today looking in the Analyze and the Graph menus. The Analyze menu, I often will start in distribution when I'm exploring data. So if I want to summarize data, I will often start by going to Analyze, Distribution, and I'll pick some of these variables, maybe age and sex and height and weight, to explore the distributions of these variables. So if I say OK, you'll see one of the awesome features of JMP is that if I click on a bar, like the 12-year-olds, I can see the distribution of the 12-year-olds through all these other variables. Or if I click on a point, like the lowest height, I can see that person's height show up in all the other variables, so I can see that was a 12-year-old male. And if I hover over this, this is where you can actually see those label features. So when I hover over this lowest height point, I see that this is Robert. His height was 51 inches, and here's his little cartoon picture. And if I want to pin this, I can click that little red pin that shows up, and now he's fused. This label is fused onto this plot. If I want to get rid of it, I can click the X. So I can click around and sort of explore the relationships between these variables. I can see this heaviest weight student is Lawrence, and I can see that he also has the highest height in the data set. He's a male and he's 17 years old. So this is one place for me to start to explore some data. Another thing I might start with is to go to the Graph menu and choose the first option here, Graph Builder. So I went to Analyze and Distribution. Now I'm going to Graph and Graph Builder. In Graph Builder, I have these drag and drop zones where I can drag variables around to see what kind of plots I might create in the various drop zones, and using this ribbon along the top. So I'm going to drag the height into X. As I drag across, you can see there are drop zones that appear, and as I hover over them, I get to see what will happen if I were to drop in these drop zones. I'll drop height here in the X-axis. Right now you can see that one point is, this is Lawrence, is this dark black color, and the other points are a lighter gray. This is because in the distribution output I had selected just Lawrence. So he was selected back in the data table. He's the only row right now that's selected. You can see there are 40 rows and one row is selected. If I scroll down, we can see that that selected row was Lawrence. If I want to have all the points highlighted instead of having just one, I can just click off of where the points are, but still in the middle of the plot. So if I click here, now they're all highlighted. Now if I go back, I can see that there are 40 rows and I don't have a single row highlighted. Instead, I have all of the points are brought to the foreground. And now I might want to pull another variable onto this plot. So I'd like to look at the relationship between height and weight. I'm going to drag weight into the Y zone. Again, if I hover around, you can see different options that would happen if I dropped in a different place. But I'll drop in the Y zone. And I see in the ribbon that I have a shaded blue color over these two options. So I have the points assigned in this plot right now, and I have this smoother line assigned in the plot. On the left-hand panel, I see more information for the points and the smoother. For the points, I could ask for the mean for various levels of height instead of just looking at the individual points. Right now I have no summary statistics. For the smoother, I have an option to use the lambda parameter to smooth it less or to smooth it more till it becomes just a straight line. So I always have more features that I can customize here in this left-hand panel. I can also ask for additional or different options from this ribbon along the top. So if in addition to the smoother I want the straight line, I can pull essentially a regression line onto the plot here. So now I have the smoother and I have a best fit line. Now the line of fit gives me more options, like I could put the equation onto my plot. I could pull this density ellipse on, where I'm seeing where the density of most of the data fall. I could pull this connecting line on. This green line is connecting the mean for various values of height. So anytime there's multiple values at the same height, that point is right at the mean. I could pull on the bars. The bars are showing the same thing that green line is showing. I could pull on a heat map and see the red shows places where there's a lot of density, a lot of points, and blue shows not very many, and gray is sort of in the middle. So I've made quite a mess now of this plot. I really don't, this is a very bad idea as far as a visual. This is not the final picture that I would want. So I have the option to undo the various steps that I put on, or I could click start over to get back to the beginning. In this case, let's click start over, and I'm going to drag the height onto X again, the weight onto Y. And now let's maybe explore some of these other variables. And instead of the smoother, I'll click the smoother off. I'll put the best fit line on alone. Let's look at this maybe, perhaps we'll group by age. So I could group them along the Y-axis or along the X-axis, or I could overlay the ages on top of each other, or I could make a different page, so a different plot for each age. So here's for the 12-year-olds, here's for the 13-year-olds, the 14-year-olds, the 15-year-olds, and so on. Or maybe instead of doing this for age, I'll do this for the two sexes, the males and the females. So again, I can group by X here. You'll see other zones sort of appear here on the side. So there's other ways I could explore the data as well. I'm going to overlay these. So I have the line for the females and the line for the males, and I'm going to add that equation back on here. So I can compare the intercept and the slope for the males and for the females. And again, because I have those label features, if I hover over a point, I can pin that point into my plot. So I've called out a few of these students here. And when I'm happy with this, I might click done. And there are many ways I can take this back out of JMP. One simple option is to select this fat plus sign, the selection tool. You can also find it in the tools menu here. The selection tool lets you kind of grab what you want to copy, and then you can just copy and paste it out. Control C, Control V, copy, paste it out. Another option is to go to the File menu and go to Save As on the Windows or Export on the Mac. And here I have an option to save it out as an image file type. Or I could save it out as HTML or HTML5 if I had an interactive element. I could drop it straight into a PowerPoint. I could save it as text if I'm saving a table or something that makes sense without saving it as an image. So there are many ways to get this out. Another way to save this is to go to the red triangle, go to the very bottom to Save Script to Data Table. Even though I didn't use the scripting language, you didn't see me type any scripting language, all of my pointing and clicking was doing something with the scripting language in the background. So JMP was saving the scripting language as I pointed and clicked, and I can now save that background script into the data table. I can give it a name like weight versus height, that's fine. Say OK. And now you'll see in this panel in the data table, weight versus height at the bottom. If I close this, and now back in the data table, just click on the play button by weight versus height, I get back exactly what I just did. It reruns the script that corresponded to my pointing and clicking. And I could even look at the script if I want to. If I right click on this and edit, I can see what the JSL, the JMP scripting language, looks like for exactly what I did in Graph Builder. It's showing me that I had height as the X and weight as the Y, that I overlaid the sex variable. It's showing me that I applied the equation for the line of fit. And it's even showing me where I added those pin annotations for those labels. So you can use JMP without the scripting language, without ever using the scripting language explicitly, or you can start to learn the scripting language if you want to extend JMP. And one way to do that is by looking at the scripting language that's in the background. Okay, let's look at a couple other ways to summarize data. I might be interested in making a table of my data instead of a graph. So we went to Graph and Graph Builder to look at graphical options, but under Analyze, Tabulate, this is where table options will be. So Tabulate gives us, again, drop zones, similar to Graph Builder, but for making a table. So maybe I would like to look at height. I'm going to summarize height. And it looks like my drop zones disappeared, but again, when I drag a variable over, they'll reappear for me. So right now I have the sum of height showed up by default. This is maybe a bad default. If I wanted to change that, I can click on this default statistics down here. Or I can change it just by dragging in a different statistic. So I'd rather look at the mean height. So the average height of these students is 62.6 inches tall. If I wanted to split this out maybe by the ages, I can drag age over here. And you might have seen, I'm going to drag this back off. When I drag, little blue outlines appear to show me places that I can drop this. So I just dropped it on the left-hand side and it added age and split this out. So now I see the means for the age groups. Maybe in addition to mean, I'd also like to look at the N, the sample size in those age groups. Maybe I'd also like to look at the standard error of the mean. And so again, as I hover, you can see different drop zones appear. If I drag it on top of mean, it'll replace the mean. If I put it next to mean, it'll put it next to mean. And if I want to do the same information for the weight variable as well, I can grab the weight variable and I can highlight all of the information I've been collecting and say, yeah, I want the same thing for weight. And so if I let go while hovering over the mass of the data here, it's going to make a new, essentially a set of 3 columns here to do the same thing for weight. If I want to split this out also by sex, I can put that before or after age. If I do it after age, it'll do age first and then sex. If I grab it and put it before age, it'll put the sex first and then the age. And when I'm happy with my table, I can click Done. And again, I can use the fat plus sign, the selection tool, to copy it out, or I can go to the File menu to save as or export to save this out in many different ways. Let's look at a couple other graphical tools that have to do with mapping. I'm going to open this SAT by year data set. This data set has a row state applied. You can see this color here. Alabama has a blue dot next to it. Alaska has a red dot. I'm going to click up here above the rows here and right click and click Clear Row States so that we can start fresh as though this is a data table that's brand new and we didn't have all these extra features applied already. So I'm hovering up here, right clicking, Clear Row States, and now those colors are gone. Now I'll go to Graph and Graph Builder. And a great feature of JMP for making maps is that there are some built-in map shape files. And these files will identify if you have a column of data in your data table, for example, state names. If you drag this column name into this special spot called map shape in the Graph Builder, JMP will look through that column and see, oh yeah, I recognize Alabama and Alaska. This is state names. I know what to draw to make that map. So if I drag state down here into map shape, JMP has a special file it's checking that's going to draw the boundaries of these states. So all I need is the state name Or there's also a map shapefile for country names, and there's one for county FIPS codes as well. So you can do a map of the U.S. counties, the U.S. states, or all the countries of the world if you have a column that has any of those pieces of information. Another option is to use latitude and longitude to make a map. I'll show you that in a moment with a different map. So latitude and longitude I drag into the X and the Y instead, but I use the map shape box if I have just one column that has the names that JMP can recognize as shapes. Okay, so maybe I want to look at how expenditure on education was in 1997 for the various states. Which state had the highest expenditure? Which state had the lowest expenditure? So if I drag expenditure on top of the map, it's now colored by expenditure, or I can drag it over here to the color box. It does the same thing. The default when I drag in the middle is to put it into the color box. So now we have a map that's showing the highest expenditure of 1997 in red, the lowest in blue, and sort of in the middle is in gray. If I want to change this color, I just double click on the color bar, change the color theme maybe to the sequential, so lightest to darkest, say OK. And so now I have it, the lightest states are the lowest expenditure, the darkest states are the highest expenditure. I'm going to click Done and show you another repeatability feature. So we talked about in the red triangle, save script to data table would save this map back to the data table with a little green play button right here in the top left-hand corner of the data table. Also, very near this save script to data table, the redo button gives me this option to do a column switcher. This swaps out one of my variables for other variables. And that's what I want to do here. I want to remake this map for things that are different than expenditure for the other variables. So I'm going to switch out expenditure with other variables. So I'm going to use redo column switcher, swap out expenditure, that's the thing I want to switch, and I'm going to swap it out with the other variables that are continuous that would also make sense to look at on a map. So I'm going to take all of these variables, ACT scores, SAT scores, the percent taking the SAT and the ACT, and so on, and we're going to swap them out. So if I hit this play button, I can now see the map repeating over all of these variables. I can hit stop, I could click through them on my own. So again, if I want to save these out, I can use the fat plus sign to copy these, or I can use the file menu and I can save as or export each of these individually, the ones that I'm interested in saving. Okay, and let's look at one more example of plotting, again with a map, but this time with latitude and longitude and with something at a smaller scale. So we're going to look at the San Francisco crime data. And I'll leave the row states this time. So these are colored by the category of the offense. This is crimes that happened in San Francisco in the month of April 2012. There were 9,134 recorded crimes in that month in the city of San Francisco. So if I go to Graph and Graph Builder, now I don't have one column to pull into map shape. Instead, I have the latitude and longitude to drag in. So I'm just going to drag them right into the middle, and JMP is smart enough to know that longitude goes on the x-axis and latitude goes on the y-axis, but it's not smart enough to know not to put this smoother on. So it's still treating these as just two continuous variables, so it put a smoother line on. I'm going to click to get that off. And then here's a big tip. When you need to put a background map on this, so this is a map, but it doesn't look like a map because there isn't anything in the background to show us that this is a map. So when I need to get a background map to show up, because I didn't use this map shape box, I right click while I'm hovering somewhere in this plot. I right click, I go to Graph, Background Map. I use this very frequently, so I would recommend, if you're new to JMP, write this down somewhere because I think you're going to find this very useful. So when you pull something into the X and Y, the latitude and longitude, then hover your mouse anywhere in the middle of the plot, right click, Graph, and Background Map. And in this case, I could ask for a simple earth or a detailed earth. These are just flat background maps. Or if I have an internet connection and I have data like San Francisco that's at the street level, I might use a street map service instead. This is going to be like Google Maps in the background. And it tells you here this is coming from OpenStreetMap. So I'll click OK. and you can see it pulls down the map in the background. I can drag to zoom in or use the zoom, the magnifying glass tool. And then maybe I'll click done, and I'll show you another cool feature from the red triangle. So we looked at save script to data table. We looked at redo column switcher. Let's look at the local data filter. If I click on local data filter, I might filter by, for example, day of the week. I'll add a filter for day of the week, and let's just look at the crimes that happened on the weekend, Sundays and Saturdays. So now I'm seeing in this region of the map just the crimes that happened on Saturdays and Sundays. And if I add another filter, so I want Saturday and Sunday and an additional filter, now I can filter by, let's maybe look at the category of the incident. I'll add that filter. So let's look at just the arsons that happened on Saturday and Sunday. So now you can see in this region it looks like there's 1, 2, 3, 4, 5 arsons that happened in this geographic region on Saturday and Sunday in the month of April 2012. And again, if I want to save this, I can use the plus sign. I can save this out as HTML5 in a number of different ways. Okay, now let's jump into some analyses. We'll talk about some basic analyses first. I'm going to open this fitness data set, and an important thing to understand about JMP is that it is a context-dependent statistical software. You're going to populate these dialog boxes with variables, and JMP will give you different options depending on the context of the variables. So if you have something continuous, JMP will give you options that relate to a continuous variable. If you look at something categorical, JMP will give you options for something categorical. So if I go to the Analyze menu, I'm going to see this really clearly in the Fit Y by X platform. You'll notice you're not seeing any names like ANOVA or Regression in this analysis platform, because these are all embedded in the same dialog boxes. It just depends on the context of the Y's and X's that you're asking for an analysis of. So let's go to Fit Y by X. Remember, distribution was looking at univariate distributions, one variable at a time. Fit Y by X is one X and one Y. It's bivariate relationships with one X and one Y. So if I drag, in this data set, the idea of this data set is that we would predict oxygen uptake, this oxy variable, based on features of these runners, like their sex, their age, their weight, how long it takes them to run a mile, what their average pulse is when they're running a mile, what their resting pulse is, what their maximum pulse is while running the mile. So I might look at oxygen uptake as the response and maybe the weight as a factor. In this case, this context, if I look down here with a Y with a response that is continuous, I will either get a regression or an ANOVA. I'll get a regression if the X is also continuous. So I'm in a situation where I'm going to get a regression. Or if I'd use a categorical response with a continuous response with a categorical predictor, I'd be in this one-way ANOVA situation. So I could look at that same thing if I just drag sex over here. So weight as the X and oxy as the Y will give me regression. Sex as the X and oxy as the Y will give me a ANOVA type situation, actually a t-test because there's only two groups. Likewise, if I put something categorical into the response, I would get logistic regression or contingency chi-squared analysis, depending on whether I have a continuous predictor or categorical predictor. We'll just look at this situation with oxygen uptake as the response and weight and sex as our factors. But note that even though I put two factors here, the analysis is going to be separated for those factors. This is a platform for one X, one Y. So it's going to split these into two different analyses. So I'll say, okay, here's the oxy by weight. Here's the oxy by sex analysis. So this is the ANOVA sort of situation. This is the regression sort of situation. And I use the red triangles to find many more options. So for example, fitting a line, I would find here. Again, I would find even more options under the next red triangle. It's a progressive interface as well, and so as I do something in JMP, it presents more options for me to follow up with that. Like I could look at the residuals for that linear fit. I could add confidence curves to this plot, or I could go back up to this upper triangle and add something different, like a cubic fit to this. And so here I see the cubic fit superimposed on top of the linear fit. And I see I can tuck away the linear fit and just look at the polynomial degree 3 fit. I could tuck that away. I might look at a spline fit and pick a lambda to start with, but then I can make it much more spliney, sort of overfit the data, or I can underfit the data and it turns into just the linear regression here. And I can easily see them on top of each other. So I have many options from these red triangles that give me further options of what I can do, like saving predicted values and residuals, and so on. On the ANOVA side, I have totally different options because it's a progressive interface and it's context dependent. So here I see things like do the ANOVA, which in this case is a pooled t-test, or do the t-test that isn't pooled that gives different variances for the two groups, or do a non-parametric equivalent to that. So let's look at a t-test here. So here's the unequal variance t-test. If I want to compare that to the pooled t-test, I can see the one-way ANOVA here is the pooled t-test. It says assuming equal variances. This one is assuming unequal variances, and so I can compare. The p-values are incredibly close. And if I wanted to see what were the actual standard deviations in those groups, maybe I'll ask for the means and standard deviations for the groups. I'll tuck some of this away so it's not so busy. And so here I see the standard deviations were very close for the two groups. So the pooled and unpooled tests end up being very similar in this case. So the FitY by X platform is a great platform, especially if you're learning ANOVA and regression, logistic regression, chi-squared test. But as soon as you need to have more than one Y or more than one X, you're going to need to grow out of the FitY by X platform and into the Fit Model platform is most likely where you're going to move. So multiple regression and ANOVA with multiple variables, they're going to be under this Fit Model platform. So let's move into Fit Model. And here for fitness, if I wanted to predict oxygen uptake with weight and sex together in the same model, I can select them and add them. If I want to put the interaction between them into the model, I can click one of them here and one of them here and click cross. Or if I wanted to build this full factorial model really quickly, I could select sex and weight over here, use this macros and the full factorial button, which will make that whole, both main effects and the two-way interaction right away. And then I can also use this platform to do many things beyond just regression or ANOVA or logistic regression. Right now, the default is this personality called standard least squares. This is a typical ordinary regression. I can do stepwise model selection here. The generalized regression platform has a lot of advanced options in it, including changing the response distribution, using censored data, and if I click run, I'll also get some other additional options like a model launch to do penalized regression methods. So generalized regression is very flexible. Mixed model lets me add in random effects. So if I were treating one of these variables, if I had a categorical variable that was a random effect, I could add it here into the random effects box. Or if I had a repeated measures situation and I wanted to look at a different correlation structure, I could add that here. So the mixed model personality is where I can add a lot of random effects, repeated effects. MANOVA, if I have multiple response variables, and so on. But I'm going to stick with standard least squares, which is where I'll get more traditional regression and ANOVA methods. The emphasis is just what do I want to have as my default output. So I'll just ask for a minimal report first, and I'll click run. And so what I actually ran was essentially an ANOVA model. It has a regression component and it has a groups component. So it's a regression with groups. So I have a line for the females and a line for the males. And because I put their interaction in, I allowed a different intercept for both lines and a different slope for both lines. And you can see the standard output, the parameter estimates, and so on. The red triangle will give us many more options, like I could look at the studentized residuals, press. I could look at indicator parameterization estimates, sequential tests, multiple comparisons. I can ask for additional things in the regression report, and I can save things like the hats, the Cook's D. I can look at studentized residuals here, save the prediction formula or the predicted values or residuals back to the data table. So any of these save columns options will save them back to the data table. Publish will save the prediction formula into a new feature that came out in JMP 13 called the Formula Depot. And I would recommend watching the predictive modeling webinars if you're interested in learning more about comparing models. The Formula Depot is described in detail in those predictive modeling webinars. Another feature that I really like is the profiler. So if I look at factor profiling and profiler, this gives me a visual interpretation of what the model is telling me. So this says for a female who weighs 77.445 pounds, maybe this is kilograms, this person is going to have an oxygen uptake of 50.414 with a confidence interval on that mean prediction of 47.44 to 53.38. If I switch same weight but switch to a male, that drops from a mean of 50 to a mean of 44. If I move around to different weights, I can see how the prediction changes, and I can also watch these confidence intervals grow or shrink in areas where I have more confidence and less confidence. So I think the profiler is a really helpful tool to understand what your model is telling you, what those predicted values are really doing across the space of your factors. Okay, let's open the Titanic passengers data set to look at some logistic regression options. This data set has whether or not passengers, these 1,309 passengers survived the Titanic, what their passenger class was, 1, 2, or 3, if they're male or female, their age, and a few other variables of interest. So if I go to Analyze and fit Y by X, here I can use their survival as the response. So this puts me in these two options. I can get logistic regression if I have a continuous predictor, and I can get a categorical contingency chi-squared test, a contingency chi-squared test if I have a categorical predictor. So if I use passenger class as the factor, then I'm going to have this situation. And if I use age as the factor, I'm going to have this situation. Because of age, we'll have to select a target level. I'm going to predict survived. The ones are they did survive, the zeros are they didn't. So I'm going to predict the ones. I'll say okay. And so these are the other two options I can get out of fit Y by X. Here's the categorical chi-squared situation. Here's the logistic regression, situation. And again, I get standard output for the chi-squared contingency table. I get the contingency table, and then I get some chi-squared tests. For the logistic regression, I get the logistic regression fit details. And again, I get more options here in the red triangles to do follow-up tests that would make sense. So a Cochrane-Armitage trend test would make sense here, or an exact test if I wanted exact test options. Now, if I move from wanting just 1x and 1y, remember I go from fit Y by X, 1x and 1y, to fit model when I want to get to more advanced methods with more x's or more y's. So I'll move to fit model for the logistic regression as well. I'll put survived in as y, and now nominal logistic pops up as my default. I'm going to keep that, change the target level to 1. And I'll put the passenger class, the sex, and the age as factors. And maybe let's do this as a full factorial. So here we get the main effects, the two-way interactions, and the three-way interaction. Nope, I didn't. Oh yeah, here's the three-way interaction. Passenger class by sex by age. So I'll click run. And again, I get standard output. Passenger class is the most important factor here. Sex is the next most important factor. Passenger class by sex is also very important, and so on. And I'll look at the profiler again. So I get lots of options from the red triangle, but I'll choose the profiler so that we can again explore as I change what passenger class, whether I'm female or male, and what my age is. I can explore that parameter space. I can see visually the effect of that interaction between passenger class and sex, because the trend for females of 1 to 2 to 3, 1 and 2 are pretty similar, 3 is a big drop, is different than the trend for males, which is 1 then has a big drop to 2 and 3, which are pretty similar. So we actually see visually that significant interaction effect. And then I can also see how age is related in this. And what I'm getting on the side is the probability of yes survived, or the probability of no did not survive. So in this particular factor setting, passenger class 3, male, is a 7-year-old child, has a 73% chance of not surviving. And then if we move into the predictive modeling options under Analyze Predictive Modeling, Partition is going to give me ways of partitioning the data to create a predictive model. So to find out who survives and who doesn't by partitioning those variables. So let's click on Partition and explore this a little further. So I'm predicting survival based on those same variables, passenger class, sex, and age. I'll say OK. And I see first visually the blue strip here, that's how many people survived. The red strip is how many people didn't. So I can see proportionally more people did not survive the Titanic than did. If I click split, I see that the most predictive split, if I want just one feature to tell me did you survive or not, the thing I have to ask was were you female or male? If you're female, your chance of survival is pretty high. If you're male, your chance of survival is pretty low. And that is the biggest way I can split whether or not you survive. If I can only ask you one question, that's a question to ask. If I want to look at the counts, I'm going to click on Display Options and show the count. So here I can actually see there were 809 who didn't survive, 500 who did. When we look within females, we see those rates, the counts, and the probabilities changing. If I click split again, I see where's the next most predictive split. And so I see within females, the next best question to ask is, if you're a female, were you passenger class 1 and 2, or were you passenger class 3? I can see passenger class 1 and 2 females had a very high chance of survival. Passenger class 3, it's closer to 50-50. If I click split again, I see the next most predictive split happens in the male branch of this tree, and that's were you a child younger than 10, or were you 10 or older? So we can see very clearly the story of women and children first, that the women have the highest chance of survival, and if you were male, your only real chance of survival was if you were a child. So we can watch that story sort of play out here as we keep clicking split. If I click split again, the next is if you were an adult male or older than 10 or older, then if you were passenger class 1, you still have a chance of survival, very tiny chance for 2 and 3. So that's under the Analyze Predictive Modeling. That's a partition. Bootstrap Forest and Boosted Tree are other kinds of partition modeling where you're creating a whole bunch of partition models in a forest, or for a boosted tree, you're creating one. Then for the remaining information that you didn't explain, you create a further tree and then yet another tree for what isn't explained by your second tree. That's called boosting. So there are other similar options here. Neural networks are here as well. Under specialized modeling, this is where we'll find nonlinear and time series. Screening shows us some ways to explore outliers and missing values, to do a market basket analysis. So if you want to look at someone's grocery list and say, okay, if you bought avocados and bread, are you more likely to also buy asparagus? So association analysis is here. Let's look at some multivariate methods and clustering. I'm going to use this body measurements data set to look at multivariate. So this is just measurements on people's bodies. So each row is a different person. And if I go to Analyze and Multivariate, the first option here, Multivariate, if I select all of these, I can look at the correlations between all of these. So this is where I'm going to get correlations between lots of variables. So by default, I just get a table of the correlations and then a scatter plot matrix showing the same thing. So here in blue, the darker the blue, the higher, closer to 1. So the higher, larger correlations are dark blue. If we had negative relationships, those would be in dark red, and relationships close to 0 will be really light gray. So we can see variables that are more closely correlated with each other, like waist and mass are very highly correlated, whereas height and bicep are not as closely correlated. We can then do further analyses, like look at non-parametric correlations here. We can look at principal components from this platform and outlier analysis if we wanted to look at Mahalanobis distance, for example. Item reliability is under this menu option, and some other ways of viewing the data. Let me show you clustering on this other data set, this birth-death data set. I'm going to again remove the row properties, so I'm hovering my arrow here, I'm right-clicking and clearing these row states. And let's get a map up first. So I'll go to Graph Builder, and the country is one of the things JMP has a map shape file for, so I'll drag country into map shape. So here I see the map. I get a little warning that a couple of these country names have changed in the map shape file. It doesn't recognize the names that are in the column, so I could go back and fix that later. And maybe I'll make this a little bit larger, or even just change the dimensions a little bit to make this a little more attractive. If I drag the birth rate on top of this plot and click Show Missing, I'll see the outline still for the map. So here I can see where there's high birth rates versus low birth rates, or if I pull death rate on instead into color, I can see this information for the death rate. But if I decide I'm going to cluster, or I could even look at the region just to see how the regions are categorized. So I can see the regions here. If I decide to cluster these data, so let's pull color back off, I'll go to Analyze and Clustering, and I'll choose a hierarchical cluster because I don't have a ton of data, so this is going to work well. And I'm going to cluster these on the birth and death rate. So I'm going to pull birth and death rates into Y, say OK. And so I see this dendrogram grouping the different countries that are similar to each other on birth and death rates together. I see this little diamond that's indicating there are 9 clusters selected right now by default based on this clustering history. If I want to choose a different number, I can drag this, or I can select how many clusters I want. So maybe I want 6 clusters. And then it will move the diamond to the place where I get 6 clusters. If I now ask to color the clusters, you can see they color here in the dendrogram, and they also color over here in the map because, again, everything is connected. So now I have actually applied a row state. So if I go back to the data, now you see colored points. That's how we get these row states, is by applying them in different ways, like coloring the clusters is one. I can also save the clusters back to the data table. So here it tells me Afghanistan is in cluster 1, Algeria is in cluster 4. And you can see it highlighting as I'm clicking through. And so what I see on this map is that North America, for example, and Australia are in the same cluster. We have similar birth and death rates. And a lot of South America and Central America have similar birth and death rates as well. So that's how clustering works. And I want to save just a little bit of time to talk about text analysis as well. So I'm going to open a really simple sample data set called Pet Survey. These are fictional answers to the question, think about your cat or dog. What's the first thought that comes to mind? So we have some responses like, my cat loves to sit in my lap and purr. I'm allergic to cats, so now we just have a dog. And if I want to summarize these data, I can go to Analyze and Text Explorer. And I take the column that has the text in it. In this case, I only have one column in my data set, but I take that text column and click it into text columns. I might choose to stem and say OK. So now the word dog and the word dogs get grouped together. That's what stemming means, is it takes a stem that's in common. If I hover, I can see that's dog and dogs. For cat, it's cat. Cats plural and cats possessive. I can see that dog is the most common term, dog or dogs together. That occurs 94 times. Cat, 73 times. Bark or barking or barks, 24 times, and so on. If I want to add some phrases to the analysis, so this is the analysis here. These terms on the term list are what are going to be in the analysis. Phrases is convenient. It shows me out of convenience what the phrases are, but if I want these to be included in my analysis, I need to highlight them, right-click, and ask to add phrase. It's adding phrase to the analysis. So now they're showing up over here. The phrases are now in the term list. They're now part of my future analysis. If I want to not include a word, like, what is this try? Let's first look at it to explore this further. So I'll right-click and show text. My cat slid backwards as he tried to go up the icy ramp. My cat tries to sit in my lap. Cat trying. My kids are always trying. If I decide that this is not a valuable word, that's not giving me insight into my data, I can right-click it, and I can add it as a stop word. This means don't include it in the analysis, so now it's removed. And now I might do things like look at display options and show word cloud. So here's the word cloud. It's just a line really, so maybe I'll choose a different layout. I'll center this. You can see dog is just said so many times. Maybe this word cloud will be more meaningful to me if I remove dog and cat because they're just swamping this so much. So maybe I'll add these as a stop word here by right-clicking. Do the same thing for cat. And now I see those more secondary words, what is said very often. So sheep is said 6 times, and if I right-click, I can show the text and see when that's said. Dogs keep my sheep from wandering off, herding the sheep. Sheep were herded. So there's a lot of people in this data set were talking about sheep when they were talking about their dogs and cats. Okay, I can also color this differently by clicking on this color or by asking for arbitrary colors or to color by another variable if I have one. So if I go to coloring and arbitrary colors, I can make this pretty. It's just randomly pretty, but it's pretty. I can also ask for saving the document term matrix. So if I do this, and let's just take the top 5 terms. I'll use binary weighting and say okay. So what this does is it, after ignoring the words I included as stop words, so it ignores dog and cat, the next 5 most commonly used words are bark, walk, jump, mice, and video. And so it creates me indicator variable columns for those terms. So this row number 9 has the word bark in it. Row number 16 has the word bark in it. 18 has the word bark in it, and so on. So I can now use these indicator variables in a predictive model. So these could now be factors in another model where I'm trying to predict some other variable. I can also do things from the Text Explorer itself as far as analysis, like I could look at a topic analysis, or I could cluster the terms or the documents. Let's look at a topic analysis. I'm just going to keep all the defaults right now. I'll say okay. Let's just look for the top 4 topics and I'll say okay. So we see sort of a picture of what's happening with essentially a principal components analysis. It's looking for different dimensions, which documents or terms group together. This first picture is of the documents, the second is of the terms. So if I click on these, I can see this is snow, take the husky, sled, and winter. So these guys are grouping together because they often occur in the same sentences together, in the same documents together, and they're obviously about winter sort of things with huskies. I can see maybe this set of topics up here: sun, now, taught, climb, back, instead. I'm not really sure what the context of these might be. I can see that they correspond to this particular document, row 106, so I could explore that further. So I can explore these dimensions by just hovering over them and seeing what they are, or asking to show the document back in the data table. But here I see the topics that really showed up. So for topic 1, here's the loadings on these. The term winter, sled, huskies, this topic that we saw over here is topic 1. So we can tell there's sort of a theme going on. This is a winter, husky, in the snow sort of theme. Topic 2 is this one I saw up here, which was sun and climbing and fences and teaching. Outside, maybe allergies. So this seems to be another topic. Topic 3 is video and hilarious, funny video of the cat. So this seems to be about hilarious cat videos. Interesting that bathtub shows up. So maybe there's some funny videos of cats falling in the bathtub. And then the 4th topic, someone, lap, jump, like, people, food, protect, guard. I'm not sure that this is a cohesive topic, so we may want to try looking at only 3 topics or look at 5 topics. Maybe this will split out into something more interesting. So we'd want to play around with how many topics we look at. We can then save the topics back to the data table. We can save information on this, which again we can use for further analysis, or we can just use this as an analysis on its own to explore what sort of themes came out in this unstructured text data. And so what we're doing is we're taking unstructured text data and creating some structure for it. Okay, so we went through a lot of different menu options today in JMP. We talked at the beginning about lots of features in the help menu. Use the books, use the searchable JMP help, use the sample data library to find these sample data sets and play around with them. The tutorials are awesome if you haven't looked through these, if you'd like to learn how to do a test of one mean or two means, or partition, which we talked about briefly today. Tip of the day is a great way to extend your knowledge about JMP. The statistics index, if you want to know how do I do an ANOVA in JMP, because you can't find ANOVA because the word isn't under here and you'd just like to find it by the word, you can use that statistics index to search by word. The scripting index helps you learn our scripting language if you're interested in that. And sample data, again, is that indexed list of examples that we think are great illustrations for specific topics and a bunch of different calculators and ways to teach concepts if you're teaching intro stats or advanced statistics. And then we talked about, in the Analyze menu, we talked about distribution for univariate statistics, fit y by x for 1x, 1y. But for any of these 4 types of analyses, we talked about fit model when you have more than 1x or more than 1y. We talked about tabulate for making tables, text explorer for this analysis of text data. We talked a little bit about predictive modeling, specifically the Partition platform. We glanced through some of these other platforms. We looked at multivariate under the multivariate methods, and we looked at hierarchical clustering under the clustering option. Under graph, we spent some time in Graph Builder, making pretty typical types of graphs, but also some geographic maps. And remember, the trick for the geographic maps is to right-click in the back, go to Graph and Background Map. So I think that's a good summary of some of the things that we talked about today. If you have more questions, please visit our jump.com/teach and look at some of those recorded webinars, what's in our learning library. Go over to community.jump.com and look in our user community, and certainly send us questions. My email address is here visible on the screen, and I'd be happy to answer questions if you ever have them. Thanks for joining today. I hope this was helpful.